Okay, so I just want to finish this, these slides off with just some conclusions and summarize everything that we've done so far. So if we take a look, where are we here? Okay, so I just solved this problem in the last video. So again, we're just using the pendulum equation to solve for this, and the added complication was to take this hours and make it into seconds and find the period from that, and then from that we could find the depth by equating it to the length of the pendulum like that. So when we do that, okay, so I just wanted to run through this really briefly with you, just to show you in conclusion what we can say about simple harmonic motion. So if you notice what this is going through, so we're comparing the pendulum to the horizontal spring system. So notice as we change this amplitude of the, change the angle, we're changing the amplitude, and same thing. This is the equilibrium position, this dotted line, and notice that at this position, in both cases, our velocity is 0, but our acceleration force is directed back toward the equilibrium position in each of these cases like that. And same thing at equilibrium, we have the maximum velocity, and since there's no stretch and there's no displacement, our forces are 0 at that case. And notice the direction changes here. That's the biggest change from here to here is the directional piece. We come back to the equilibrium, etc. like that. So in terms of what to study for, I would definitely study these diagrams and understand what's going on, but not only just like looking at these and memorizing them, but think about what goes on. When a pendulum swings all the way, it stops briefly, and then it's going to have its maximum velocity at the bottom, and then keep going at the top like that. So kind of break down your problems logically to help you solve them out. And again, this is just a nice image of what we just discussed. So for solving spring systems, this is a set of equations we can use for the most part. Notice that if we want to know the energy of a spring system, we have to include any piece that has a stretch or a elastic potential energy, and the object will be moving, so we'll be using kinetic energy. But you can use this to solve your systems. And x will equal to a at the maximum point, so you could use that to help you solve problems. And of course, the force for springs is negative kx, as explained, so the strength of your spring and how much you stretch it. So for pendulums, the equation we basically have is this one right here, where we relate it to the period. Very similar to what we did over here. You could write the frequency as the inverse. So what you can do is write it as 1 over 2 pi, and you could write it as 1 over 2 pi g over L for frequency, but either way you can look at the frequency and period through this. And then the energy for a pendulum will be related to its gravitational, so that's the biggest change right here. So if we're looking at the energy at the minimum, the midpoint, or I'm sorry, not the midpoint, but anywhere that's not the extremes, we have to include both the height at that point and the velocity. And the hardest thing is if you're not given this height, you have to solve it out using trigonometry, specifically like the cosine piece that we solved earlier. Okay, so that would be it for simple harmonic motion and oscillations. You'll find the 12 problems will be related very much like the ones that you've seen here. And then next, when we get back, we'll go into another topic.